Okay, so here's the next big thing, and this is how gravity works with these equations. Now, the good thing is, there's no new equations to learn. It's still the same 4 equations, okay? It isn't like, oh, gravity has special equations. No, they're the exact same equations, okay? There's nothing new. It's just how you apply them. Alex, I don't have time. So here's the story. So when you look at gravity problems, there's 2 broad classifications of gravity problems. One situation, I drop it, okay? The other situation, I throw it up in the air like this, or if I have anger issues, I throw it down like that. That's it. The only 2 types of gravity problems are, okay? You either drop it or you throw it. If you drop it, and this is going to be huge, your initial velocity is going to be 0. If you throw it, your initial velocity is not going to be 0. If you throw it up, your initial velocity is going to be positive. If you throw it down, your initial velocity is going to be a negative number. Now, you are assuming that you are on Earth, unless I explicitly tell you different. Like you're on the moon, you're on Mars, something like that. If I don't tell you anything different, you just assume that you're on our normal rock, okay? Technically, that has a value of 3 significant digits, negative 9.80 meters per second squared. It varies depending upon where you are on the Earth. If you're on the top of Mount Everest, it's a little bit less. If you're by the ocean, it's a little bit more. We'll talk more about that later. But here's what's going to be important. That's technically going to have 3 significant digits. So when you do calculations involving this, your answer should also have 3 significant digits. Amongst the long list of things that annoy me, do not tell me, oh, gravity is negative 9.8. That is so wrong on so many levels, okay? Gravity is not negative 9.8, okay? You can say the gravitational acceleration is negative 9.8 meters per second squared. You can say little g is negative 9.8 meters per second squared. But do not go, oh, gravity, it's negative 9.8. This makes absolutely no sense whatsoever, okay? 0 zip. But here's what's going to be the same. Whether you throw it or you drop it, gravitational acceleration is going to be negative 9.8 meters per second squared. On all of these problems, whether I throw it or if I drop it, anything going down, velocity, acceleration, displacement is going to be a negative value. Anything going up, velocity, acceleration, displacement is going to be a positive value. Okay? No exceptions, none, 0 zip. There you go. When it lands, so one of the things we're going to calculate like is how fast that golf ball was going when it hits the ground. Do not tell me, oh, it's 0 because it hit the ground. No. What we're talking about is how fast is it going just at that point of impact. And because on all of these, that ball is going to be going down, your final velocity is going to be a negative number. Okay? So those are just kind of the operating parameters. So we're going to work 2 types of problems. One where I drop it, one where I throw it. Okay? So, here's the story. So I'm going to hold this ball up to a height of 2 meters, which is about yay, and I'm going to drop it. Okay? So here's the ball. It's 2 meters above the ground, and I'm going to drop it. And I want to figure out how long it's going to take. I want to figure out how fast it's going when it lands. I want to draw the position time graph and the velocity time graph. Okay? So I want to do all 4 of those things, and all I know is how far it falls. But hidden within this is some vital information. What's going to be the initial velocity of the golf ball?
0 meters per second.
Oh, so I don't tell you that explicitly, but you know V naught is going to equal 0 meters per second. If it was anything else, I would have to tell you, okay? I'd have to say, hey, I threw it down at 2 meters per second, or I threw it up at 4 meters per second. So unless I tell you something differently, and something just like falling, you assume that the initial velocity is going to be 0. Okay? Cool with that. Now, let's talk about the position, time, and the velocity. So we're going to kind of work backwards. So here's the ball, it's 2 meters above the ground. We need to establish the reference point. Do you want the reference point to be the point that I let go of it? Or do you want the reference point to be the ground? Let go. We're going to make that the reference point. So we're going to make that 0.0 meters. Now, this is going to be huge later on. Anything going down is going to be a negative value. So if I start at 0, okay, what's going to be my final position?
2.
Positive 2 or negative 2?
Negative 2.
My final position is going to be negative 2 meters. With that being said, here's going to be my position time graph. It's going to start at 0. I'm going to give you 2 different curves for the position time graph. It's going to be the lower lip or the upper lip. Beacon, upper lip, lower lip.
Upper lip.
Why?
Because as the gravitational acceleration increases the velocity over time, it gets faster and faster before it hits the ground.
So how is that shown on the upper lip?
The golf ball accelerates, so the slope gets steeper and steeper.
Because what does the slope of the position time graph represent?
The velocity.
So slope gets steeper, it's falling faster. So it's going to be this. So what that means is that when it lands, that's going to be negative 2 meters. Go with this. Good so far. Now, what's the velocity time graph going to look like? Where's it going to start?
Sorry, 0.
0? Is it going to slope up or is it going to slope down? Mr. Etheridge. Wow. Mr. Etheridge, what's it going to do? Slope up or slope down? You got a 50-50 shot.
Down.
Beautiful. Straight line, curved line.
Straight.
What's the value of the slope? What's the acceleration caused by gravity? It rhymes with 9.8.
9.8.
Positive or negative?
Negative.
Negative. So if you were to draw your velocity time graph, it's going to go something like this, and the slope's going to be your acceleration, which is going to be negative 9.8 meters per second squared. Cool? Okay?
Cool.
Now, if you were to find the area of that triangle, what would the area of that triangle be?
This.
How far does it fall?
2
2 meters. So that area should be
2 meters.
positive or negative?
Negative.
Negative. See, everything has to fit together. Okay? So when you draw your velocity time graph, because you're going to end up landing with a negative velocity, my displacement is going to be a negative value. That's also going to match my position time graph, which is going to have an increasing negative velocity. So I can't have this showing a negative displacement here and my velocity time graph going up like that, because that would be a positive displacement, but my position time graph would show a negative displacement. So both graphs have to show the same thing happening at the same time. Cool with this? Okay. Let's tackle the time problem. So I need to find time. So could I use V equals V naught plus AT to find my time? Andrew.
Yeah.
Nope. Why? Do you know your initial velocity?
Yes.
Do you know your acceleration?
Yes.
Do you know the time?
No.
Do you know your final velocity?
Maybe.
No,
No.
you don't. You don't know your final velocity. We haven't found that number yet. So I can't use this because I don't know what my final velocity is. All I know is that it fell 2 meters, but that isn't my velocity. Okay?
Yes.
Does that make sense? Okay. So that's a good equation. I just can't use it at that point. Could I use distance equals 1/2 AT squared plus V naught time? Sydney, your thoughts?
Yeah,
Why?
you have displacement, we know
Yes.
acceleration, and our initial velocity is 0.
So this part of the equation drops out, right? Cool. Nice, right? That's why it's dropped. If I throw it, that does not drop out. But since I'm just going to drop it, that part's going to go away. Connor S., I need this equation solved for time, and I hate fractions.
2D over A.
2D over A, and then do what?
Square root
Square root of it. Now, this is not a big dog equation. It's more like a pup, okay? This is a handy-dandy little equation to have, like, filed away in your back pocket. But there's a caveat. It only works if the initial velocity is 0. Okay, if the initial velocity is not 0, you can't do this. Now, listen to me very carefully. What I'm about to do is wrong. Okay? Do not do what I'm about to do. It's wrong. Okay? I'm going to tell you straight up. Mr. Brookcamp, that's wrong. I'm telling you, I know it's wrong. Okay? But here's what you're tempted to do. Oh, I got 2 times 2 meters divided by negative 9.8 meters per second squared. Okay? Now, why is this mathematically going to be a problem? Connor S.
You can't take the root of a negative number.
Sure you can. What do you have to use, though?
Oh, you have to, yeah, imaginary number.
Yeah, I'd have imaginary time. Okay? Which is cool if you're in preschool, right? It's like, oh, it's imaginary time. Nice. Okay? No. Okay? So can't do this. So there's a couple of things that you can do. One is you can just ignore the negative sign and act like it's not there. Is there a negative sign there? Nope. I didn't see a negative sign. Not there at all. I don't recommend that. Could I just randomly make that a negative 2 meters, though? I can't randomly make it negative 2, but is it negative 2?
Yes.
Oh, this is where this problem flows into one big idea. So, because of the fact that this is displacement, not distance, it's displacement.
Right.
Okay? What's my displacement? Mr. Hanna? It rhymes with negative 2.
Negative 2.
Oh, negative 2 meters. Winner, winner, chicken dinner. Now, when I do that, now what happens? Oh, now I have 2 negatives underneath the radical. It cancels out. Now I have this problem fixed. Now, don't sit there and go, man, Brookhamp, do we have to really worry about this? Like, in the greater scheme of things, do we have to worry about 2 negatives underneath the radical? You do, because of the fact that you have to view the whole problem, okay? I promise you, last problem you're going to do on your test, Friday, we'll work this problem tomorrow. It's going to be a ball thrown off of the building. One of the things I'm going to make you do is show me all of the calculations. And one of the things I'm going to look for is that are you consistently using negative acceleration and positive or negative displacement, okay? That's one of the things I'm absolutely going to go through with a fine-tooth comb on your work. I'm going to tell you straight up, okay? If you do this, let's say you just have positive 2 and a negative 9.8, I am snarkily going to write, wow, imaginary time, cool, okay? Loaded with sarcasm.
Oh.
So pay attention to the little things. Now, here's the other thing that you're going to do, Ron. Mark my words. You're going to take 4 and you're going to divide it by 9.8, and then you're going to forget to take the square root. Okay? Promise you, it's going to happen. And you all sit there, Andrew's shaking his head. It's like, Miss Brookhamp, we won't do that.
You lie.
You lie.
I would not.
You forgot.
Okay? You lie. I know this is going to happen. So somebody do the math. Take 4 divided by 9.8 and take the square root of that. 3 significant digits, what do you get? 0 point something.
0.64.
6 what?
4.
3 significant digits.
Oh, 638.
You took 9, oh, you divided by 4?
0.638.
What's the number after 8?
0.639.
Oh, yeah, 9.
4 divided by 9.8.
Seconds.
You're
Okay?
good, bro. You're good.
Now, here's what this means. Now, I can come over to my velocity time graph, and I know that's 0.639 seconds. I can go to my position time graph. That's 0.639 seconds. Now I'm starting to fill in the pieces of the puzzle. Okay? So 0.639 seconds, if you consider like 1 Mississippi to be like 1 second, if I drop this at the same time I start counting, 1 Missa, so 1 Missa is equivalent to 0.639 seconds. Okay? If you do the conversion. So what that does is that it tells me, hey, this seems like a reasonable answer. If I drop the golf ball and I go 1 Mississippi, 2 Mississippi, we're like, whoa, 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 something's wrong. The observed time was much longer than what I predicted. Something's wrong. Okay? My calculations aren't right. So that's the beauty of physics. You say, hey, if I drop this ball from 2 meters above the ground, it should take 0.639 seconds for it to hit. And then we can time it and go, hey, does it match? Okay?
Yes, sir.
Good with that. Now, we have one thing left to do. We have to figure out how fast it's going when it hits. Now, I want to dispel a common myth right now before we go any farther. In physics, okay, not a math class, in physics, let's say that you're comparing 2 velocities, -2 and -20. If you're in a math class, which one's the bigger number, -2 or -20?
-2.
Why?
Because it's close to 0.
Closer to 0. So in a math class, -2 is bigger than.
-20.
Now, you're in a physics class. I'm going to give you 2 options. I'm going to throw this golf ball at you and it's going to hit you in the head. Situation number 1, it can be traveling 2 meters per second. Situation number 2, it can be traveling -20 meters per second. Which one are you going to pick? -2. So do not tell me, oh, -2 is less than -20.
No.
No. Okay? Or -2 is greater than -20. In a physics classroom, all the negative sign does is indicate direction. Okay? I promise you, a golf ball going -20 meters per second is faster than a golf ball going -2 meters per second. Okay? The negative sign just indicates direction. Okay? That's all it does.
Yes.
Now, here's the next big question. We need to figure out how fast it's going when it lands. Thatcher, listen to me very carefully. When that ball hits the ground, is it going to be going less than -9.8 meters per second, like maybe -5, something like that? Is it going to be going exactly -9.8 because of the influence of gravity? Or is it going to be going faster than -9.8, like maybe -12, something like that?
Less than -9.8.
Why?
It hasn't been a second yet, so it can't reach -9.8.
Ah, it's a beautiful answer. Okay? So here's the story. The slope of this line, according to Mr. Etheridge, is -9.8 meters per second squared. So for every second that goes by, how much does the velocity drop? 9.8 meters per second, right? That's what the number means. True? So if the ball fell for exactly 1 second, how fast would it be going?
9.8.
-9.8. Did we fall for an entire second?
No.
We fell less than a second, so therefore the velocity is going to be less than -9.8. Now I'm going to show you 2 ways you can get to this point. Both have their advantages. If you are willing to roll the dice, if you're
I'm a good gambler. I don't know.
Okay. If you're willing to roll the dice, and this is a huge roll of the dice, that the 0.639 seconds is right. If you're assuming that the time is right, or correct, whatever you're going to put that, could you use V equals V naught plus AT?
Yes.
Yes, why?
Because you have all the.
You know the initial velocity?
Yes.
0. Do you know your acceleration?
Yes.
Negative 9.8 meters per second squared. You know the time?
Yes.
0.639 seconds. Okay? So, Connor S. Take that answer of 0.639, multiply that by 9.8. What do you get?
Negative 6.26.
Negative 6.26 meters per second. Does that match what Thatcher said was going to happen? Because the answer is less than negative 9.8. Cool with that. Well, what's the downfall of this? Alex?
You're hedging on time.
Yeah. If my time is wrong, guess what?
That is wrong also.
My velocity is wrong. That's the roll of the dice. Is there a way you can find velocity without using time?
That equation.
That equation. Oh. Could I use V squared equals V naught squared plus 2AD? Dylan, could I do that?
If you're missing the time, right?
I don't have time. You
Yes,
know V
right?
naught.
Yes, right.
That goes away, right? It's a good thing I like you. Now, that's going to go away. So V is going to equal the square root of 2AD, correct? Go with this. Now, here's the story. What I'm going to do is wrong. I'm going to go, 2 times negative 9.8 meters per second squared times 2 meters.
Here we go again.
Why is that wrong again?
Negative 2 meters.
I'm going to have an imaginary velocity.
Imaginary
Cop
velocity.
pulls you over. How fast are you going? I don't know. It's an imaginary velocity. I don't know. Okay? That's a recipe for a DUI. But what's the rescue?
Exactly.
Actually,
To a
I
negative.
started going this way.
It is displacement for a reason.
So I'm not going 60.
Now,
I'm going 60.
this is where your calculator lies to you. Or at least it doesn't tell you the whole truth. Punch this number in, what do you get? What does your calculator say the answer is? No.
The same thing as before.
6.26. But is 6.26 the correct answer?
Yes.
No.
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 It's not.
Which direction is it going?
Negative. Left. Down.
What's the square root of 4?
2.
Or?
Negative 2.
So what do? You choose the
Yeah,
negative. Okay?
I mean,
So the advantage of this is that you use known values. The disadvantage is at the end is that you have to pick the negative root.
I roll the dice.
This one, the advantage is that it automatically generates a negative time. What's the disadvantage?
You get time.
You have to use your time. Okay. Now, very quickly, because I only got about 5 minutes to get through this. Ms. Dawson, pick a number between 20 and 30.
24.
Okay, so I'm going to throw a ball straight up in the air at 24 meters per second. Boom. It's going to go like this. Okay? Now, and hopefully not drop. Boom. Straight up 24 meters per second. That's the only number that you know. I want to draw a velocity time, a position time. I want to find time up, time down, max height, velocity and height at 1 second, and the velocity and height at 3 seconds. And I know one number. But what else do you know?
We're going A to Z.
Acceleration.
I know the acceleration. right? Acceleration is going to be
Negative 9.8.
meters per second squared. When it reaches its maximum height, what's the final velocity going to be?
0 meters per second.
Oh, so I know when it's at its maximum height, the velocity is going to be 0. What's my velocity time graph going to look like? Where's it going to start? At 24 meters per second.
Okay, there you go.
What's it going to do? Straight, curved.
Straight.
Where's the ball at that point?
Time.
Velocity is going to equal 0. It is at max height. Thatcher, is my time up going to be bigger or smaller than 1 second?
Bigger.
Why?
It makes sense, I don't know.
It's gonna take more than 1 second to
What?
go negative.
Ah! What if my initial velocity was 9.8 meters per second? How long would it take to go to 0?
1 second.
1 second.
1 second. Is my velocity bigger than 9.8?
Yes.
Therefore, my time up is going to be bigger than
1 second.
1 second. Okay? What can I use to find my time up?
D equals 0 plus 18.
V equals V naught plus AT?
You gotta solve that first.
I need to solve this for time. Luke, solve this for time. What do you get?
V minus V naught over A.
Now, I'm going to do this wrong. Oh, that's 24 meters per second divided by negative 9.8 meters per second squared. Why is that going to be a train wreck?
Because you're going to have a negative time.
I'm going to have negative time. If you ever generate negative time, something is wrong. Do not write down a negative number and then go, oh man, that's bad. And then just erase the negative sign. I see it happen all the time. If you generate negative time, figure out what went wrong. So, but what if I take 0 minus 24?
That's gonna be negative 24.
Oh, then I'm going to have negative 24 divided by negative 9.8, and that's going to be cool, because then I'm going to have positive time, right? So somebody take 24 and divide it by 9.8. 2 something. 2 point what? 4.5. So that's going to be 2.45 seconds. So if it took 2.45 seconds going up, and if it's symmetrical, and if that's a huge if, what do you know about your time down?
It's gonna take 2 points.
It's going to be the exact same. That's also going to be, so you're going to, total time is going to be about 4.90 seconds. So if it's symmetrical, the time up is going to equal the time down. Max height. If you're willing to roll the dice on your velocity time graph, and if you're willing to roll the dice if this time is right, what could you do to find your max height?
V equals V 9
No. All you have is your velocity time graph. Well, how could you use your velocity time graph to find your max height?
Find the area.
Find the area of that triangle. 1/2 base times height. But what are you assuming?
Your time is correct.
Your time is right. If your time is wrong, your max height is wrong. How can you find max height without time?
That equation.
That equation. So you could use your max height, you could use V squared equals V naught squared plus 2AD. What would you have to solve for? Distance. So what would you have? V squared minus, yeah, V squared minus V naught squared all over, that would be your distance. Now the other thing that you could do, and this is going to play out large later on, you could do 1/2 AT squared plus V naught time, but you'd have to use half your time. You'd have to use the 2.45. This is a cool equation because it's a function equation, because it tells you how high you are at a function of time. You could plug in any value of time, 1 second, 2 seconds, 3 seconds, 2.45. What if you plugged in the entire time? The entire time for the flight, what would you generate as the value of D?
It'd be
0.
0. Why?
Because it comes back to your hand.
That's going to be back at your hand. Okay? There you go. Okay, let me hand out the assignment right quick because I know Southie's got to go.
Do it.
Oh, that equation is just
What?
I feel good. So, that's when you sit back.
Right. Oh.
This time.
Now keep that going.
Besides, I'm gonna watch the video.
I got stuff to do. Okay, so on 1 through 4, do not use gravity. Don't use gravity. When you get to question number 16, do not use that equation. Okay? 16, do not use that equation. That's all I got for you. Now you can do it. So,
Wait, so what
Andrew,
equation?
stop yonder camera.
Wait, so which equation do we not use for number 16?